Now next question that we are going to study is from July 2017 exam, question X. So guys, give the heading July 2017 exam, July 2017 exam, question 8. Okay. Now I am going to read the question. So please read this question with me carefully. We have a box whose mass is how much? 60 kg. Yeah? See the scenario here. What we have? We have one box whose mass is how much? A box whose mass is how much? 60 kg. Okay. We have a box whose mass is 60 kg is on a plane inclined at 30 degree to the horizontal. So we have a plane. A box is on a plane, on inclined plane. That plane is making 30 degree angle with respect to horizontal. Now what they have given next? The coefficient of friction between the box and the plane is how much, guys? So they have given us a mu. So how much value of mu they have given us? Value of mu is how much? 0.4. How much is the value of mu? Mu value is how much? 0.4. Okay. Now try to see the next scenario. Now I am going to read the question. Okay. Before that I am going to draw the drawing of the question. Okay. So what we have? We have what, guys? One inclined plane. This is what our inclined plane. On that inclined, this is what a horizontal. With respect to horizontal, how much plane is making angle? 30 degree. We have a box. Okay, this is a box whose mass is how much, everyone? How much is the mass of the box, guys? 60 kg. How much is the mass of the box? 60 kg means 60 kilogram is the mass. Okay, and coefficient of friction is 0.4. Okay, now try to see the scenario what they are asking us in the A part. Okay, please be careful with me for the A part. Calculate each of the following. Okay, what they are asking us in the A part. Calculate each of the following. Okay, number A, the time taken for the box. Okay, see what they are asking us in the A part. Time taken for the box to slide down the plane. Okay, time taken for the box to slide down the plane a distance of 15 meter from the rest. Okay, means from where? Okay, see in A part what is our target? Try to see the scenario here. In A part what they are asking us? They are asking us time. Okay, what they are asking us in, guys, A part? They are asking us time. For what purpose? The time taken for the box to slide down the plane. Okay, to slide down the plane a distance of 15 meter. So if distance is 15 meter means what? That is our displacement. So S will be how much? 15 meter. So this is what a displacement. 15 meter will be what a displacement. From a rest, guys, underline that word rest. From rest under the effect of gravity. What they are saying? From rest under the effect of gravity. So what is meant by from rest? From rest means what? Starting from a rest means what? Its initial is what? It is stationary. Initially it is what? A stationary. When they are saying from rest, it is initially stationary means what? Initial velocity will be what? U will be what, guys? 0 meter per second. Try to see the scenario here. So now what they are asking us in the A part, they are asking us time to cover a distance of 15 meter when starting from a rest. Okay, guys, are you getting my point? So that is what our target in A part. Now, so I am explaining you once again our target. What is our target? In A part, what is our target? Object going to move down. Okay, what is our target? Object is going to move it down. Means motion of the object is going down. This is what the motion of the object. And this object, when it is going down, it is covering how much distance this block is covering? 15 meter. So, and it is starting from a rest. Starting from a rest means what? Whenever they are saying starting from a rest, it means what? Its initial velocity will be what? Initial velocity will be 0. Okay, so try to see this point here. So what they are asking us here? So for covering this 15 meter distance, when starting from a rest, how much time is required? Okay, so indirectly, so here what they are asking us? They are asking us a time. What they are asking us, guys? Time. Okay, now try to see the scenario here. How we are going to do? How we are going to solve such type of numericals? Okay, so we have to find out time. Now we studied, guys. Now first of all, before going further, can we apply equation of motion in gravitational field here? Can we apply equation of motion in gravitational field? Means we studied equation of motion in gravitational field. Can we apply equation of motion in gravitational field here? No, because there will be normal reaction will be there, friction force will be there. So we can't apply equation of motion in gravitational field. Okay. Normal equation of motion is applicable here. Okay. Now try to see the scenario here. What is our target? We have to find out time to cover the distance of 50 meter when object is starting from a rest. Okay. Now how to see the scenario here? We know this relation. S is equal to ut plus half pt square. S is equal to what, guys? Ut plus half pt square. Okay, how much S is here? 15 meter. Initial velocity is how much? 0. So U into T 0. Half into A into T square. So what is our target? We have to find out time. So in this equation, what is unknown? Time is unknown. So what? 15 multiplied by 2. Okay, 1 minute. Don't write anything. Divided by A is equal to what, guys? T square. Okay, so T will be equal to what? Under root of 30 by A. So if we need a time, what we need, guys? If we need a time to cover a distance of 15 meter when object starting from a rest, what we need? What we need, guys, here? We need an acceleration. What? Yes, what we need, guys? We need an acceleration. Okay, are you getting my point? Try to see the scenario here. What we need? We need an acceleration. Now, so what is our target? First of all, okay, don't write this scenario, anything. Don't write anything. So what we have to do? We have to find out what we have to find out. We have to find out first of all acceleration. Now how we are going to find out acceleration? So here motion is in which direction? Here motion is in which direction? Okay, see, as usual our x and y direction. Okay, so first of all we are going to draw x and y direction. So how to draw x and y direction? X is in the direction of motion. We studied these things in the friction chapter. X always along the plane in the direction of motion. And what about y? Perpendicular. Okay. Now what are the forces here will act? First of all, its weight. How weight will act, guys? Everyone? Weight always act vertically downward. And what will be its weight? Mass is what? 60 kilograms. So weight will be what? Okay. And always remember, weight must be vertical line. Huh? You got the meaning of vertical line. Same vertical line. Sometimes few people draw weight like this. It is not a vertical. Huh? Sometimes some people may draw like this. Not some people. In my college days, I may used to draw the weight like this. Huh? So please be careful with such type of things. Weight should be how we have to draw the weight. Weight should be always, guys, vertically downward. Vertical. So this is what our weight. Weight is how much, guys? Weight is how much? 60 g here. In this scenario, weight is how much? 60 g. See. Now then, this is what our weight. Weight is how much? 60 g. G stand for acceleration due to gravity. Then here there will be what? This will be what? Everyone? Normal reaction. Normal reaction is what? Normal to the plane. Then motion is downward. What about friction force? Friction force will be what? Opposite to the motion. So motion is downward, opposite to the motion along the plane. So this will be what? Our friction force Fr. Okay, everyone, everything is okay till now. Now see, this 60 g is neither in x direction nor in y direction. This Rn directly y, Fr negative x. Okay, so what we have to do? We have to take the components of 60 g. And how to take the component? We are going to form a rectangle. See, this side is what? Perpendicular to the plane. This side is what? Parallel to the plane. Again perpendicular to the plane. Parallel to the plane. So we have to get the components. One component will be like this. See the scenario here, everyone. Huh? One component is like this. Another component will be what, everyone? Like this. And this angle will be what? Same this angle, 30 degree. We studied all these things in our previous chapter. Okay, so this is what? 30 degree. So this component will be what? 60 g cos 30. Everyone, is it okay? This component 60 g cos 30. Sine, correct, sine, very good. So guys, please be attentive with such type of things. So this will be, component will become what? 60g sine 30, and this component will be what, everyone? 60g cos 30. Okay. Now what is our target? What we have to find out? We have to find out time. And for time, what we need? We need an acceleration, guys. What we have to find out? We have to find out time. And for time, we need an acceleration. Without that, we can't get up. Okay. Now how to do? See, is there any motion in y direction here? Is there motion of this object, of this block? Is there any motion of this block in the y direction? There is no motion in the y direction. Okay. There is no motion in the y direction. So can I write down here? So guys, can I write down here? Summation of forces in y direction equal to 0. Because as there is no motion in y direction, it means what? Summation of forces in y direction will be equal to what? 0. Okay, guys, are you getting my point? Means see, basically it will be MAY. But as there is no motion in y direction, so we can write down directly equal to 0, because if there is no motion means no acceleration, and acceleration will be equal to what? 0. So in y direction situation is an equilibrium situation. Okay guys, anyone have any doubt in this discussion? As there is no motion in y direction, okay, so we can write down equal to 0. Now try to see the next point here. Everyone try to see the next point. Okay guys, any doubt in this discussion? Now what are the forces here in y direction? What are the forces here in y direction? Okay, first of all, what is first force? Rn. Positive y direction. Then next force will be what? Minus 60g. What? Cos 30. Okay, try to see the scenario. Will be equal to what? 0. So Rn will be equal to what? 60 multiplied by 9.81 into cos 30. Everyone please do the calculation and tell me the value. Everyone please do the calculation. So Rn will be equal to what, guys? 509.7426 unit Newton, because reaction force in Newton. Okay. Now we got it, Rn. Then friction force will be, guys, here object is in motion, so friction force will be equal to what? Fr will be equal to what? Mu Rn. Frn is equal to, Fr is equal to what? Mu Rn. See, N must be in suffix, guys, everyone. So Fr, how much value of mu? How much is the value of mu, everyone? Value of mu is how much? They have given 0.4, okay, into Rn. Just now we calculated 509. Check it, guys. Let me know if you have done any mistake. In 0.7426, okay. So what will be the answer, guys? 509.7426. How much, guys? We are getting answer 203.897 Newton. Okay. So we got Fr. What we got? Fr. What is meant by Fr? Friction force. Now, guys, here motion is in which direction? Here motion is in which direction? X direction. And here velocity is not constant, guys. Here velocity is not constant. Okay, because initially it is rest. See, how do we come to know that it is velocity is not constant? Because initially it is in rest, and after some time it is starting from a rest, and speed is increasing. Okay, guys. So here velocity is not constant. So here we can't take summation of forces in x direction equal to 0. We can't take. So by Newton's second law of motion, summation of forces in x direction will be equal to what? Is equal to ma. Okay, mass into acceleration, because along the direction of motion there is a direction of acceleration. Okay, guys, here I am drawing A. Okay, so guys, please try to see the scenario here. Okay, everyone. So acceleration is always along the direction of motion. Okay, try to see the point. Acceleration always along the direction of motion. Okay, that's the point I am telling you. Okay, there is a few some exception in one chapter. In that chapter, I will tell you how to handle with that is simple harmonic motion chapter. But till that chapter, always remember we are going to take acceleration always in the direction of motion. So here acceleration motion is in only one direction. So guys, see, basically while dealing with Newton's second law, I told you summation of forces in x direction equal to max. And summation of forces in y direction equal to what I told you guys in yesterday's lecture, in last lecture, may. Okay, but here is there any motion in y direction? If there is not any motion in y direction, what will happen? If there is not any motion in y direction, what will happen? It will become equal to what? 0. What will happen, guys? It will become equal to what? 0. Okay, try to see the point here. So it will become equal to 0. So it is become 0. So, and here there is only motion in x direction. So instead of ax, what we have written directly? We have written directly ma. Okay guys, any doubt in this discussion? So directly, that's why we have written directly ma. Okay, because there is motion only in x direction. Instead of writing max, means acceleration in x direction, because there is only one motion in x direction. Okay, so we have written directly ma. Okay, now try to see the scenario. Okay, any doubt in this discussion, guys? And here summation of forces in x direction is not equal to 0 because situation here object is not moving with constant velocity or not stationary. Okay, then and only then we can apply equilibrium equation, otherwise we can't apply equilibrium equations. And here we have applied equilibrium equation in y direction because there is no motion in y direction, so that's why we have written directly summation of forces in y direction equal to what, guys? Equal to 0. Okay, any doubt in this discussion, guys? Shall I go further? Okay, good. So now try to see the scenario here. Try to see the scenario. What are the forces? See, forces in the direction of motion we considered as a positive, opposite forces negative. What is the force in x direction here? 60g sin 30. It is the directly, so we can consider it as a positive. See the point here. 60g what? Sin 30. Okay, what about the next force? Next force will be what? What about next force? Minus Fr is equal to ma. And what is our target? We have to find out acceleration. So how to get acceleration? A is equal to what? 60g sin 30 minus Fr divided by what, guys? M. Okay. Anyone have any doubt in this mathematically? This is just mathematical part. Okay. So acceleration will be equal to what? 60 multiplied by 9.81 multiplied by sin 30 minus Fr is how much, guys? 203.897 divided by mass is how much, everyone? How much is the mass? 60. So please everyone do the calculation and tell me the value of acceleration. Very simple numerical, guys. If you are good with friction chapter, then this chapter is too easy, not that much difficult. Okay guys, how much value we are getting? Everyone? Anyone? Okay, 1.5067. What is the unit of acceleration? Don't miss a unit, huh? What is meter per second square? Okay, unit of acceleration is what? Meter per second square, huh? Meter per second. I told you in yesterday's lecture what is meant by acceleration. In every second, how much velocity is changing? That is physical meaning of accelerations. That's what we discussed, guys, in yesterday's lecture. Huh? Try to see the point here. Now, try to see what is our target. We have to find out t. So, how to get a t? So, we got the acceleration. So, what we got, guys? We got the acceleration, and then how to get the t? How to get the t? So, under root of 30 divided by acceleration is how much? 1.5067. 1.5067. So please everyone do the calculation and tell me the value of time. Everyone please do the calculation. .4622 unit second. Okay guys, are you getting my point? Try to see the scenario here. So in this way we got the time. What we got, guys? Time. Okay. Now how to write? You have to do First of all, write down these two given things. First of all, guys, what you have to do? First of all, write down these two given things. Then A part target. These two things, displacement. This is mean by, what is the meaning of U? U stand for initial velocity. After writing down these things, draw this drawing. Below that, then this one. After that, this one, and then this side. Okay, guys, everyone getting my point? First of all, this, and then at the end. Okay, please everyone write down all these things. Now guys, what is our target in B part? Okay, try to see the scenario. I am going to read the B part carefully. In B part, what they are saying? The force, what we have to find out in B part? We have to find out force. The force applied parallel to the plane to accelerate the box at 2 meters per second up the plane. Okay, try to see the scenario. In B part, what we have to find out? We have to find out force F. Okay, what we have to find out? We have to find out force F, okay, to accelerate the block, okay, up the plane. Now here in A part, how is the motion? How was the motion in A part? In A part, motion was downward, okay, and there is no any external force. Only this, there were only three forces acting. First one is weight, second one normal reaction, and third one friction force. But here in B part, there is a fourth force is also there, and that fourth force is what? How is the fourth force? The force applied parallel to the plane. Okay, on the box, how we are applying the force? We are applying parallel to the plane, and to accelerate the box 2 meters per second square. Okay, how is the acceleration of the box, guys? Acceleration is how much? 2 meters per second square. Okay, and how is the motion? How is the motion? How is the motion up the plane? Okay, see the scenario here. Motion is how? Motion is up the plane. Okay, try to see the scenario here. Now again I am going to draw the new drawing for this B part. Okay, and how to draw the new drawing for this B part? Okay, everyone try to see the scenario here. So this angle is how much, guys? 30 degree. This is what a box. Okay, here we are applying a force F, okay, which is what? Parallel to the plane. We can apply force here also, no problem. Okay, so here we have applying force F, which is parallel to the plane. Here we have a weight. How much will be the weight of the box, everyone? Weight will be how much? 60 g. Okay, then there will be what? Normal reaction. This is what? A normal reaction. Normal reaction always normal to the plane. How is the motion in this scenario? How is the motion? Motion is what? Okay, how is the motion? Motion is up the plane, and there is acceleration is always in the direction of motion. Okay, now then motion is upward. Then what about friction force? Friction force will be what? Downward along the plane. Friction force will be what, everyone? Downward along the plane. So this is what our Fr. Okay, now this 60g will have how much component? 2 component. Okay, now before that we have to show x and y direction. Y direction is always perpendicular to the plane, and x direction along the plane. But how we have to consider x direction in this scenario? Because motion is upward, so how we have to show? So this is what our y direction, perpendicular to the plane. So this is what a y. And how we have to show x direction? Along the plane in the direction of motion. How is the x direction, everyone? Along the plane in the direction of motion, because motion is upward, and that's why friction force is downward. Okay, so that's what, so therefore what we have to take? Components of 60g, because 60g neither in x nor in y. So here try to see the scenario here. So for taking components, we are going to form a rectangle like this. Okay, and always try to draw this box bigger. Okay, because for taking components you will not feel any difficulty. Everyone try to see the scenario here. So how is the components here? See the point here. How is the component? So this component, so this angle is 30 degree. So this angle is also 30 degree. And this is another component. Okay, everyone. Try to see the scenario. So this component along the x direction will be what? 60g what? Sine 30. And this component will be what? 60g cos 30. Okay. Any doubt in this drawing? Okay. Now what is our target here? In this question, we have to find out this force F. Okay. Very, very simple scenario. Okay. Nothing we have to do. Okay. Same. Again, we will start our story. Summation of forces in y direction. Okay. We will get directly same answer as the previous one. Okay. Summation of forces in y direction here. What are the forces y direction here? Only two forces. Rn positive y minus 60g sine 30. Okay. Equal to what guys? 0. Okay. Everyone try to see the scenario. Try to write down properly always. Then Rn will be equal to what? 60 multiplied by 9.81 into sine 30. How much answer? Same as the A part. Okay. Please, how much everyone? Tell me the answer of Rn. 509.7426 Newton. Check it, answer in A part also. Does we got the same answer in A part? Okay. Then friction force will be what? Fr will be equal to what? Mu Rn. Fr will be equal to what guys? Mu Rn. Mu value is how much? How much is the value of mu? 0.4. 509.7426. So please everyone do the calculation and tell me the value of Fr. Same as the A part, everyone. How much answer guys? 203. 20. What is the blunder I have done here guys? What is the blunder I have done here? I have done a bigger blunder guys. So always be attentive. What are you doing guys? So please be careful. So it must be cos 30. Please be guys, be careful with the things. Please be attentive. Your teachers will do a lot of mistakes in the class. So you have to be always careful. Okay. You got it now. You will get that answer. Okay. Now guys, everyone got the same answer? Please check it. Is there any other mistake done by your teacher? Check it once again guys. Okay, good. So now what we have to do? So 203.897 Newton. Okay. Now we have to take what? Summation of forces in x direction equal to what? Not equal to 0, equal to ma. What are the forces here? X direction. See the x direction here. Upward along the plane. So F will become what? F will become what guys? F will become what? Positive. Then what will be the scenario? Opposite will be what? Minus Fr. Then what will be the scenario? Minus 60g sine 30 is equal to what? What is mass? 60. Acceleration is how much guys? They have given. Oh, I have not written acceleration also. Guys, see what is your teacher is doing. Please be attentive. Tell me what is acceleration here. I have written only unit. So please be careful. Guys, any more mistake? Okay, good. So what is our target? So into 2. So what is our target? What we have to find out? We have to find out F. So 60 into 2, 120 plus Fr. Okay, check it out guys. Plus 60g into sine 30. So F is equal to what? 120. How much Fr we calculated? 203.897 plus 60 multiplied by 9.81 into sine 30. Okay, everyone, please tell the value of F. Everyone, please tell the value of F. $120 plus 203.897 plus 60 multiplied by 9.81 multiplied by sine 30. How much we are getting guys? 618.197 Newton. So this is what our answer of B part. Okay guys, are you getting my point? See, if you studied friction chapter easily, means thoroughly, not easily, if you studied friction chapter thoroughly, properly, then this linear motion chapters is almost depends on our friction chapter, just only except we added only few part M into A, nothing more there. Okay, so guys, please everyone write down, first of all write down target, then write down A equal to 2 meter per second, after that this one, then this one. Please everyone write down these things properly.